Let's take a look at the front side of the worksheet after you're done now. You can take a look at some general comments. Come up with some conjectures on the back side. So, for number one, can I get somebody to discuss number one with us? What's going on here with number one? Nobody understood number one?
I'll give you number one.
I'm asking you to make comments as to what happened for each nature. Kate?
Well, the value is a coefficient with, wait, which number one? In general or?
Give me what you got, Kate. What did you gain from number one?
In general or which one?
It's up to you. You decide.
Okay. Well, we found that if it was, what's it called? The value before x was greater than 1, it became narrower, and if it was less than 1, it became wider. But if it was 0, it just simply didn't exist.
Yeah, because y equals 0 is just a flat line, right? So that's good. So this, you should have written, the line y equals 0 x squared is the line y equals 0, really, which is really just the x-axis. So you didn't even see that appear on your graph. That's something to notice for sure. If it was negative, what happened to the parabola? What did it do?
Downward, or open downward.
Yeah, it flipped like that. It looked downward. And as Kate said, if the value of a was bigger than 1, like 3, it got narrower, but when it was less than 1, it got wider, right? Like 1/2. Well, so what we can say here was what we said. Well, let's for now, for the sake of this, we say, as when a was bigger than 1, it got narrower, and when a was less than 1, it got wider. This was assuming that a was positive, though, right? Okay? Good. So that's the general things you got from the first one. We'll summarize these also. Second one. What do we got from the second one? Julia.
The y-intercept is going to be the number, but you're going to move the negative 4 over to the other side, and that's the negative side.
Okay. So what did the 4 do to the problem?
It's just like the graph didn't change, it just shifted it up.
That's the word. Say it again. Shifted. So this shifted up or down, correct? So what kind of a shift would that be called? What's the term for something moving up and down? Vertical. Okay? So what we're going to notice here is that the k value affected the vertical shift. Now, some of the k values start on the left-hand side, like they are in standard form, okay? But once you move them over to the right-hand side, you're able to see what exactly happened. So, for part A, was that a shift up or down? What was it, Joe?
Like over.
Over. No, for number 2 still, Joe. Number 2. What about part B? Part B?
Yeah.
Should have been shifted down.
That's what I said. Yeah.
Part C?
I say
And part D?
up.
Okay? So what we'll notice here is once the k value is moved from the left-hand side over to the right-hand side, we can just simply look at the sign and see whether it moves up or down. But when it's over here in the standard form, it's kind of the opposite of what you would think. Alright? So again here, this is y minus 4 equals x squared and it shifted up. But then when it was y plus 2, it shifted down. Okay, that's what we're going to talk about in a minute. We'll go back to that. Number 3. What effect did h have on the graph here for number 3? This one was pretty obvious. Come on. Chris.
Since you squared the binomial, it moved the parabola to the right or the left.
Good. So this is a horizontal shift, right? The x minus 2 quantity squared. Did that slide right or slide left?
It shifted to the right.
But the x plus 1 shifted to the... So we can say this is a horizontal shift. Okay, a horizontal shift. So what we're trying to do here is identify the parameters of a parabola that can affect its nature based on the standard vertex form we started with at the top up here. Okay, again, it's all based on this form right up here that we're going to be looking at. We'll look at standard form also. Okay, we'll look at standard form as well, but that won't be till next week. Finally, number 4 was a little bit tricky, right? What did number 4? Why was this a little bit trickier than the others? What happened here, Joe?
A lot of work.
It was a lot of work. So how about part A, Joe? Tell me what happened to part A.
Graph is wider and vertex at 1, 1.
The graph was wider. How come?
Because x is 1/3, which is less than 1.
Because A is 1/3,
Yeah.
right?
Yes.
Because the A was 1/3, it got wider. Good. Now we had a -2 on the left-hand side, which tells us to shift it up 2. And then the -1 shifted to the handbar. So if I were to graph part A already, it would look something like this, I know. I'd go up 2 and to the right 1. And I put a dot there. And that would be like my new vertex, right? We'll talk about these terms, but that would be like my new vertex. And what I would get was, if this was my normal graph, x squared, it would be a little bit wider. So it might look like this. Okay? For now, we don't have an exact method to know the exact curvature, but that's a general idea. If the solid line represented something without the 1/3, the minute you have the 1/3, it becomes much wider. Okay? So that's the general idea of what the transformation would look like. Why is it opening upward and not downward? Yeah, because A, even though it's 1/3, it's still positive. So because it's positive, it's still opening upward. Okay, it's still opening upward. How about part B? How about part B? Jared? For 4, part B.
There was a negative parabola with the vertex at 3, 0.
Good, so it opens down. The vertex you said was at 3, 0, which makes sense because this indicates shift to the right 3 units. What else? One other piece of information. It was negative, so it opened down, but it was -2. So is it going to be narrower or wider than the parent function? It's going to be narrower. So a graph like part B would look like something like this. You would shift it 3 units to the right because of the x minus 3 quantity squared, but there's no k value here, so you don't shift up or down. So you leave it there, and you put a dot here to show the vertex. Okay? It's going to open downward because k, or because a value is negative, and because it's a 2, it's going to be a narrow graph. So if this were the normal graph opening down, it would look something like this. Okay? It'd be much narrower opening downward. It'd be this inner graph right here. And I tried to draw a dashed line, it didn't work too well. Okay? So that dashed line will be the actual graph. So again, the idea of today's lesson is to get down pat the idea of transformation. Okay? There can be a k value, an h value, or an a value that can affect the problem. Those 3 things. So let's go ahead and summarize now and take a look at how we can make statements out of these. So, I gave an example there for part A, and I said, for example, when A is negative, the graph opens down. And that was called concave down. Alright? So we want to make some other general conclusions. What are some other conclusions we can make about the coefficient A? The coefficient A here. What are some conclusions we can make? Kate?
If it's greater than 1, it's narrower.
Okay, and if it's less than 1, it's...
Wider.
But we want to make sure that we care about the negative and positive sign also, right? So how can we classify that?
If it's less than -1, it also is narrower, and if it's greater than -1, it's wider.
Yeah, so anything between -1 and 1 is like a wide graph. Anything outside of 1 and -1 is a narrow graph. So let's use absolute value to say that. So when the absolute value of A is less than 1, meaning it's somewhere between -1 and 1, we get a wider graph. When the absolute value of A is bigger than 1, so like 3, 4, or -3, -4, -5, we get a narrower graph. Okay? Again, absolute value, remember, because the negative and positive doesn't affect the wideness or the narrowness. The negative positive affects whether it opens up or opens down. Okay? So again, when A was negative, it opened down, which we call concave down. When absolute value is less than 1, it's wider. When absolute value is bigger than 1, it's narrower. What about the constant value K? What about that constant value k there? What can we say about it? This is a tough one to see. Go back to your original. Go back to one of your examples. For example, here. If you had something like this, right? The general form looks like this. So if you look at this problem right away, a is just 1. It's in front of the x squared. There's a 1 here. There is no h value, so h is just 0. What's the k value in this problem? Be careful. What's the k value, Julia? 2. Okay, it's not negative 2, it's just 2. Because the standard form is y minus k, and here we see y minus 2, so k is just 2. And when you graph something like this, did it shift up or did it shift down? Which way, Joe? Up. So we could say when k is positive, the graph shifts up. When k is negative, what do you think is going to happen?
Down.
Yeah, it's going to shift down. And it's not as obvious with the negative examples. Let me show you what I mean. If you had one that said this. Okay, let's take a look here. Y plus 2 equals x squared. How do you get a positive 2? The only way you can get a positive 2 is if you had this. Y minus negative 2. What's a minus and negative give us? A positive. So if we write it like this, we can see that k is now negative 2 in this case. Again, remember the value of k is whatever comes after the minus sign up here. But because we don't see a minus sign and we see a plus sign, we have to rewrite this as y minus and then rewrite this portion as negative 2. So y minus negative 2 is where this y plus 2 comes from. So this k would be negative here. And when this happens, when k is negative, the graph shifts down. Okay, the graph shifts down. And the last but not least part is the h value. Okay, the constant value h. What do we know about h? The general form is this again. That's our general form. And if we had a problem where h was like this, let's say we had this problem. Something like that. Y equals quantity x minus 1 squared. What does that graph look like? Does it shift to the right or does it shift to the left based on your notes? From the last page, does that shift to the left or to the right? If you don't know, go ahead and type in your calculator and see. Julia? To the right. And notice, what's the h value in this part? Take a look here. Right? It should say x minus h. And this says x minus 1. So h in this problem is just 1. Again, this says x minus h over here. This says x minus 1. So h is just 1. And it shifted to the right 1 unit. So again, for this one, we could say the same thing as the k, but instead of shifting up and down, we're going to talk about shifting right and left. So when h is greater than 0, like this example here, h is 1, it shifts to the right. But when h is less than 0, it shifts to the left. Okay? It's the standard idea of vertex form for these kinds of problems. Okay? Now tomorrow we're going to have about 20 to 30 minutes in class. And what we're going to do is go over this theory behind this. Okay? So we're going to go into the notes tomorrow. No homework tonight. Okay? You don't have class on Thursday. Stop recording. You had this one. Whoops. Let's go back.